Central angles are going to be a central theme throughout our unit. This symbol is called theta. It's a Greek symbol. It's a Greek letter. It's like T of the Greek alphabet. And it's called theta. That represents our angle. So instead of referring to the angle as x, we're referring to it as theta. Okay? Theta is a central angle of circle O. A central angle is an angle whose vertex is on the center of the circle and whose side contain radii of the circle. So from C to here, that is a radius. From C to here, we have a radius, and this is angle theta, central angle. Remember how your semicircle was 3 and a little more? Do you remember how your full circle was 6 and a little more from your investigation? Okay, what is pi? 3.14. Isn't that 3 and a little more? 1, 4, 1, 5, and it never stops, correct? What is 2 pi? 6.282, probably whatever. That is 6 and what? A little bit. So how many radians are in a semicircle? Radians in semicircle was 3 and a little more, right? All right, we no longer have to say 3 and a little more. It is pi radians. Because what is pi? And little more. Pi was discovered with circles. What I believe it was Euclid, took a circle, put a triangle inside like this, equilateral triangle, meaning all sides equal, and found its perimeter. And then he did a square, found its perimeter. That's what, 4 sides? Then he did a pentagon, equal sides. And then he did a hexagon, and then a 9-sided figure, 10-sided figure, 11-sided figure, 12-sided figure. Do you agree the more sides, the closer to the circle it becomes? And what he discovered was that when he was finished, it was getting close to this 2 pi number. If you take anything round, and you were to measure all the way around that round object, and then divide it by its diameter, you come up with pi. So radians in an entire circle is, radians in whole circle is how much? 2 pi, because 2 pi is 6.28, which is 6 and a little more. These are important things to know. So I'm going to give you a test on circles, centers, radii, graphing, translating, dilating, and radian measure, arc length, sector, etc. Then we're going to have another test on the rest of it. So I'm going to break this into 2 tests, and I think that you all will be happy about that. All right. So this is what you did. Let's look at the green circle. You took the radius with your pipe cleaner, right? And then you laid that pipe cleaner across here, and you got what? This theta is 1 radian. Well, now, do you remember that everybody had a different pipe cleaner? But what do we know about the angle? They were all the same. Were the side lengths the same? Not necessarily, because some people's radii were bigger, some were smaller. So if I take this out to 2 units, did you have, oh, you didn't have patty paper. You needed your patty paper. You needed to compare. We need to do that. Let's see. So now if I go to 2, let me try to do this. Let me try to, that's pretty fat. Nope, it didn't do it. All right, maybe if I used a pen. So I'm going to trace this from here to here. Do you see that? All right, so now if I go out 2 units, do you agree this arc is bigger? But if I were to take this and I were to move it, how many radii does that take up? Well, wait a minute. There's 1, and there's 2. Here's 1. I didn't do a very good job drawing my radius. Try to do better. All right. So there's 1. There's 2. Here is 3. So the radian itself hasn't changed, but as the radius gets bigger, does it make sense that if it took 1 radius here, that when it's double its length, it's going to take 2? And when it's triple the length, it's going to take 3. And when it's 4 times, it's going to take 4. So this is what we were supposed to fill in. This arc length here is 2 radii, right? This is 3 radii, and this is 4 radii. So what we want to, as the radii grow, does the central angle change? Does it change? No, the central angle did not change. Keyword, did not change. As the radii grew, what about the arc length? It what? Grew. A central angle whose measure is 1 radian is equal to the arc it cuts off on the unit circle. Unit meaning 1. Central angle, and you saw that because your pipe cleaner was the radius. This angle theta is equal to the radian. Let's see, the central angle is equal to the length of this arc when we have a unit 1 radius. And your pipe cleaner was a unit 1. So what we're getting ready to do is fill in 11 and 12. Yeah. Okay. The length of an arc in radian measure is going to be theta times r. Okay? Let me come back to here. Remember, let's come back down here. The central angle, whose measure is 1 radian, is equal to the, I should say, not just the arc, let's say the length of the arc. Add in length of is equal to the length of the arc. It cuts off on 1 circle. 1 circle. I should say unit circle. Unit meaning radius is 1. This is a key concept in trig, unit circle. So if our radius is 2, then we say 2 times theta. If it's 3, it's 3 thetas. If it's 4, it's 4 thetas because it's 4 of those. So what letter do you want to use for arc length? Do you want to use 2 letters, AL? Do you want to use L? What do you want to do? L? L is equal to theta times R. L is arc length. Theta is the measure of the angle in radians. Measure of angle in radians. And R is the radius. In pretty much most of the higher level mathematics and your sciences, when you're dealing in angles, it must be in radian measure. So this is really important. So do you need to know this? If you have that sheet of important terms, then I would write arc length in the left column, arc length, and in the right column I would write L equals theta R. And we should go back someday and fill in a bunch of other stuff. All right, so you're going to see a lot of fractions. If I go back to a circle, let me just draw a circle. All right, if I have this circle and I want a semicircle, okay, so this is pi radians. If we start here, remember positive, we swing up. This would be 2 pi radians if I go around a whole circle. If this is 1 pi and I stop here, what do you think that is? 1/2 pi, exactly. So if this is 2 pi, I should say this is also 0 radians. 0 and 2 pi. So I'm at 0. I go to half a radian, then I'm at a full radian. What do you think this one's going to be? 1 and? We're going to write that as 3/2 pi. They usually write it in improper, and then we get to 2 pi. So what if I were to draw something in here? What do you think that's supposed to be? Supposed to split this in half. Right, 1/4 pi. And if I do the same thing over here, it's not going to be 1/4, but, yeah. Get the idea? So it's not 1/4 of a radian, it's 1/4 times pi, because remember this is 3.3 and a little more. All right, so that makes this probably look better. So this is on every single problem you do for homework. You have a worksheet. It's called, I believe, arc length worksheet. There's an A46, there's an A47. A46 said A, A47 said B and C, and I have no idea what we were talking about. I think the worksheet I have must be, I must not have kept it. But anyway, what I did is I wrote it more in EOC format, so we're going to deal with arc length. If a central angle is 2/3 pi radians, central angle, and the circle's radius is 8, find the length of the arc. First thing I want you to do is write L is equal to theta times R. Where do we put this? You got to decide. Is that an L, is that a theta, or is that an R? What is that? It's a theta. How do you know? Because one of the pi, and it says a central angle is this radian. So when you see the radian following it, that is its angle. In other words, we put 2/3 pi in for theta. All right, and the circle's radius is 8. Does 8 go for L or for R? R, because it says radius. And so what are we looking for? Find the length of the arc. Oh, that should be an H, shouldn't it? So how do you multiply fractions? You say numerator times numerator, so that's going to be 16. 3 times 1 is 3. The pi would be on top if you want to put it on top, or you tell me it is 16 pi over 3. Now, if you don't like that, then get out a calculator. If you have a scientific calculator, does it have a pi key? Do they have pi keys? Look, who has a scientific calculator? Okay, you need a scientific calculator, right? You need to get a scientific calculator. Okay, Kayla says she has a pi button. Where's the pi button? Oh my gosh, it's a big pi button. So when you use this, I want you to, Eric, when you use this, I want you to don't use 3.14. What do I want you to use? The pi button. Isn't that easier to punch anyway? I'll let you take out your staples. Good. All right. Yes. You need to get one. All right. They're not going to allow you to use a graphing calculator. And on the EOC for next year. They're not going to. You need a graphing calculator for class. They will not let you use it on the EOC. All right, so staple. Did you staple your patty paper? And excellent. All right, so now what we're going to do. So honest to goodness, if you want to be successful on this, you have to know L equals theta R. And then it's just a matter that you substitute in the right places. So Kayla's going to do 16 times pi divided by 3. And that is going to be approximately 16.75 more. Okay. Is it 5516? Okay. So I asked you, well, let's work on this too. I asked you to round to the hundredths place. Now, I didn't mark off on the last test. I might on this one. That is the hundredths place. That is the tenths place. So that 5 says that 5 should go to where? A 6. All right, C is the center of the circle. I've got theta. I've got theta to be 5/4 pi. I've got AC to be 3. That would be that segment. Find the length of arc AB. See the little arc sign? It's not a straight line. That's an arc symbol. So we want the length of an arc. L is equal to theta times R. Write that on every single problem. If you don't, you get a 3 out of 4. All right, where am I going to put the 5 pi over 4, Carlin? L, theta, or R? This. Okay, what is theta? It's my angle. Okay, so where should 5 pi over 4 go for theta? Okay, where should the 3 go? Look at the picture. Where's AC? That's the radius. So where should it go? For R. And what are we looking for then? We're looking for L. So you're going to multiply. This is going to be 15 pi over 4. I am happy with this answer. So I'm giving you the theta and I'm giving you the R. Another possibility is I could give you L and R. Another possibility is I could give you L and theta. And on your worksheet, you will have all 3. Okay, so if we look at this one, what am I supposed to do first, Travis? Right, theta times R. First thing. All right, Hope, where do I put 11/6 pi? L, theta, or R? Yes, so that's going to be 11/6 pi. All right, where am I going to put my 1/3, Nick? Why? It's the radius. So it says find the length. And this question should justify the fact that I don't know my L yet. So you're going to do numerator times numerator, denominator times denominator. Is this hard? This is angle measure. Right, now it says if the length of arc AB is 6/11 pi. Don't assume when you see a pi it's going to be the angle. And AC is 2, find theta. Let me see if I can drag this down. All right. So what am I supposed to do first? Bree? All right. Leslie, where are you going to put 6/11 pi? The R? It is not the angle. How do you know it's not the angle? Okay, and that is arc AB, and in which case, that's not a 6. In which case it goes in for, is it a radius? It is what? Is it the theta? It's the length, length of, and that's an arc symbol. So it's going to go 6 pi over 11. Okay, where do I put this 2? Becky? AC. Look at your picture. AC. What is that? Is that a theta or an R? It's an R. So what don't I know? I don't know theta. Okay? What does it say also? Does that confirm the fact that theta should stay theta? Okay? How am I, if I have a fraction on this side, instead of dividing by 2, what can I do to make my math easier? Multiply by what? The reciprocal. So we're going to have 1 over 2, 1 over 2. So this theta is going to equal 6 pi over 22. Will I accept that as an answer? Because how does 6/22 reduce? 2 goes into 6, 2 goes into 22. I bet if you had a scientific calculator, it would have done that for you. Would you put 6 over, do you know how to you work your fraction key? There's an ABC key. Do you see an ABC key on your calculator? Should be an ABC key. Maybe, there's your ABC key. Okay, so if you do if you do 6 and you do ABC, that's a fraction bar. 22 equals, look what it does. Isn't that nice? I was out of school for about 12 years, and when I went back to do my master's degree, my scientific calculator wasn't working anymore, and we didn't have graphing calculators at the time. And so I bought a new scientific calculator, and I saw this key that I'd never seen before. Oh my gosh, when I saw a calculator that could do fractions, I just about flipped. All right. So let's see what else I've got here. Tonight is just going to be, so let me go to, and somewhere it said it, so let me see if I can find the, here. An angle in radian measures equal to the length of the arc that it cuts off. Look at this wording, cuts off. Do you see that? Cuts off. Now, what you're going to see on your worksheet is subtended arc. Subtended arc means the cutoff arc. So do you see how these rays cut off this arc? That is the subtended arc. This would be a subtended arc. So that's one of the things I need you to know. All right. So if we want to find, you know how we do arc length? If we want arc length, how many degrees is it? How many radians all the way around? How many? 2 pi. So if I said arc length, let's say our radius is 2. Now we're going to say radius is radius. So if I put my angle in and I get 2 pi times my radius, have you ever seen this formula before? Where did you see this? You saw, I'm sure you saw it in middle school. No, this had to do with circle stuff. It's the circumference of a circle. What does circumference mean? Distance around. The distance around a circle is going to be 2 pi, because that is the theta measurement of that, times r. In the event that r is not 1, then it's going to be 2 pi that many times. So I just thought it was really slick how we go from this arc length right into the circumference of a circle. Your questions tonight are going to look something like the length of an arc is 15 and the radius is 9. Find the measure of the angle. So we know L is equal to theta times R. What you've got to figure out, you've got 15, right? You've got 9. What are they? What is 15? Is it an L, a theta, or an R? It's an L, so we're going to put 15 here. How do we know? Because it says length of an arc. That is L. What is 9? How do you know it's R? Because it says radius. Does your question confirm the fact that that should still be an unknown? Find the measure of the angle. So what is theta? 15 divided by 9, right? Or 3 goes into 15 5 times, 3 goes into 9 3 times. What if they said the measure of a central angle is pi over 2 radians. The radius is 3 meters. Find the length. Here's a big word. Ready? Find the length of the subtended arc. L is equal to theta times R. What do you do? What do we have? What is pi over 2? It's what? It's theta, because it says the measure of the central angle. All right, what else? What is my 3? Because it says radius. What does this subtended arc mean? That means the arc that was cut off, which would be L. So my L is going to be 3 pi over 2. So A46 is your arc length worksheet. There is no A, there is no B, there is no C. All right? It's just an arc length worksheet. A46 is an arc length worksheet. No A, no B, which means we won't be doing an A47 because A47 says do B and C. Yes. Already graded it. Okay. No, we're not doing those either. Thank you. Jennifer, do you have any absent work? Oh, wonderful.